Hi everyone. So today we will be working on our next topic, and that is going to be about the irrational numbers. So for this topic, our main objectives would be to define irrational numbers, simplify square roots, perform operations with square roots, and rationalize denominators. So first thing, what are irrational numbers? So the set of irrational numbers is a set of numbers whose decimal representations are neither terminating nor repeating. So to simply say it, these are values, these are numbers wherein if you change them into rational form, it they will not be a terminating, meaning they will not stop, their decimal place will not stop, or you will not see any pattern that is repeating. So it's just going to continue forever and ever, pretty much like that. So for example, the best example of an irrational number is pi, because even up to now, even up to now, mathematicians do not know what is the last digit of pi. And these are just a few of the digits that comprises pi. So pi is approximately equal to 3.141592, and you can see it's going to continue. You do not see any pattern that is repeating, and so this is what we call as irrational numbers. Now, square roots. So in this case, we'll just be focusing on square roots. So the principal square root of a non-negative number n, which is usually written as the square root of n, is always the positive number. Okay? So when we talk about the principal square root, okay, principal, it's always the positive number that when multiplied by itself will give us n. So, for example, if I ask for what is the principal square root of 36, well, the answer would be 6. Even though we know that negative 6 times negative 6 is also going to give us 36, because we're talking about the principal square root, we are just going to consider the positive number, which is 6, to give us our square root here. So the square root of 36, principal square root is going to be 6. Now, not all square roots are irrational. By default, majority of square roots are irrational. And you can try. If you put in, let's say for example, the square root of 3, put it in a calculator, it's going to be a never-ending value. Square root of, let's say, square root of 91, it's going to be a never-ending value, okay? But not all radicals, not all square roots are irrational. How do we know? It's because when we have the square root, let's say the square root of 25, square root of 25 is actually 5. And what is 5? 5 is a rational number. And from our previous discussion, when we say rational, we can express the number as a ratio of a numerator and denominator. And 5, we can write it as 5 over 1 or 10 over 2 and so on and so forth. All right? So just bear in mind that not all square roots are irrational. So those square roots that are not irrational, which are actually rationals, are what we call as the perfect square root. So when we talk about a perfect square, this is the number that is the square of another whole number. So pretty much these are our perfect squares. Now, knowing the perfect squares are very important, especially for later on. So our perfect squares are the answer. So 1, 4, 9, 16, 25. Even though I hope that at least these numbers you know by heart, okay? These numbers extra, I believe, okay? So just make sure that you understand that the square root of a perfect square is a whole number. So if you get the square root of 4, the answer of that is 9, which is a rational number. Okay, so these perfect squares, if you get their square roots, they are the only square roots that are going to be rational. All right, so we have square root of 0, which is 0. Square root of 81 is going to be equal to 9. Now we have some operations that involve our square roots. So we have what we call as the product rule. So pretty much the product rule says that if you have a square root and you have different values in there, you can combine them. You can simply multiply those two. Oops, sorry. You can multiply these two and share them, the product here in one square root. Or if you have a product and you can think of factors of that, you can actually have them written individually as well. All right, so let's have some examples. Square root of 25. Now, when we talk about simplifying, all right, we have to make sure that when we factor out our value here, one of the factors needs to be a perfect square, okay? And then it should be multiplied by another factor, okay? That is important. That is important. Why? Because when we talk about simplifying, when you simplify a perfect square, you have a whole number, all right? So in the case of 75, which perfect square can divide 25? Now again, when we talk about perfect square, it's these numbers, 1, 4, 9, 16, 25, these numbers. These are your first things to think of when you are factoring out your product, okay? Now, square root of 275 can be written as the product of 25 and 3, okay? Why did we select 25? Well, we know that the square root of 25 is a specific value, which is 5. And then, can we get the exact value of the square root of 3? No. So we leave it as it is, okay? So that is the simplified form of the square root of 75. Again, one of the factors need to be a perfect square, okay? If you cannot remember the perfect square, list them down on the side. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. That's 1 up to 10, okay? One of them should be one of the factors. So let's take a look at 500, okay? Which of these perfect squares can divide 500? Well, you have two choices. You can choose 25. Definitely 25 can divide 500. And also 100 can divide can divide 500 evenly. Now, out of the two, which one will you select? Well, it's always better to select the higher one, okay? So that when you rewrite the factors of 500, it will be the square root of 100 times the square root of what? Square root of 5, okay? And when you get the square root of 100, that's going to be 10. Square root of 5, you cannot simplify that anymore, so that stays, all right? The advantage of selecting the higher perfect square is that the second factor will most likely than not simplifiable anymore. That's why we are always trying to choose the higher perfect square factor. Now, let's have the square root of 17. Do we have any perfect square that can divide 17? If you notice, none of them can divide. Pretty much why? 17 is an odd number. So, this is irrational. You cannot simplify it anymore because square root of 17 is irrational. All right. So, when we say that you have an A and B that are non-negative, we can use the product, okay, to multiply the square roots. And then, of course, the product of the square root is the square root of the number. So, let's have this example here. So, now it's the opposite, okay? We have two radicals now, two square roots that we need to multiply. So, square root of 2 times square root of 5, that is simply the product of 2 and 5, which is the square root of 10. Can you simplify this? No more. That's the final answer. Here we have the square root of 7 times the square root of 7. So pretty much we're going to be multiplying 7 and 7. So that will be the square root of 49. Now check. Can we simplify the square root of 49? It so happened that 49 is a perfect square, which can be simplified as 7. Okay, so always remember, final answers are always simplified. If you have fractions, they need to be in lowest terms. If you have square roots or radicals, they need to be in the lowest possible, they should have the lowest possible radical in there. Okay, so as you can see that there will be times wherein you have irrational times irrational can actually give you a rational number. Most of the time, irrational times irrational will also be irrational. But there are special circumstances wherein you can actually get a rational number. Okay? So now in this case, we have the square root of 6 times 12. So we can simply multiply 6 and 12. That's going to give us the square root of 72. Now, let us simplify 72. Again, think about our perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Which of these can divide 72? There are two of them that can divide 72. Three of them. 4, 9, and also 36. Okay? Now remember, by default, we always select the highest perfect square as one of the factors. So square root of 72 could be written as square root of 36 times the square root of 2, which will eventually give us 6 square root of 2. So that is the simplified form. All right. Now, let's move on with quotient rule. So same scenario with the product. So if you are dividing two square roots, you can, if you can get the quotient between the numerical values inside, then you can simply use that as well. Okay? So for example, here, square root of 75 divided by the square root of 3, can we, doing a quick divisibility rule, can we divide 75 by 3? 7 plus 5 is 12. 12 is a multiple of 3. So definitely we can divide and combine them into one expression. So 75 divided by 3 is going to be 25. And simplifying the square root of 25, that's going to be 5. All right? Square root of 90 divided by square root of 2. Again, we can combine them as 90 over 2. And this will give us the square root of 45. So, how can we simplify this? We need to think of a perfect square that can be a factor of 45. So, out of our perfect squares, it's going to be a 9 times 5, okay? Always use the perfect square as the first factor. And so, if we simplify, this is going to be 3 square root of 5. All right.